What's the connection? Why data structure and algorithm is important? Anyone? Deepashri, you want to say? Hello, am I audible to you guys?
Yes, ma'am.
Okay, someone review please. No one?
Ma'am, data structures are processed by means of certain operations.
Okay, and
And
what is data
an
structure?
algorithm is a finite step,
Okay, so your
defined
program
instructions.
basically consists of two things. One is algorithm and one is data structure. So with the help of algorithm, you solve a solution, and data structures are to hold the data and organize them. So, so anyone can say what is data item. Those are I already mentioned. What is data?
Smallest unit
Okay, data
uh,
item.
where we can where we can store all the informations.
Then data item.
Mm,
What was data items? If you have a set of data, like suppose an array 1, 2, 3, 4, 5, then each unit is called data items. Correct? An entity. What was entity? Entity. What was the example I gave last time about student record?
Contacts and addresses are considered as data items.
Yes, entity. You can say just some of the attributes it has, like your name, your age, phone number, and all. Those are one entity. Then those values will be like means each attribute will have some values. Like when you have your name, you will put your name there. An entity set. What was entity set?
Ma'am, said where we can store our
Are the
integers
contacts and
and
addresses.
Yeah.
integer and characters.
Go on. Listening.
Set of entities.
Is it only entities or is it like similar entities?
Similar entity.
Ma'am, list of contacts or addresses are considered as data entities.
Okay. Entities with similar attributes form an entity set. What was field? Field is a single elementary unit of information that represent the attribute of an entity. Like if in your entity, suppose names, then the name will have some fields, like that type of field. Means each attribute you can say is also a field. Then record, what will be the record? like student records. Sorry, I couldn't hear you. Record is a collection of field values of the given entity.
Yeah, collection of field values.
Yeah. So field values means if I gather all your information, so that's a record for third sem. Okay. Then what was file? Of course, collection of records. So it goes one by one. So if data is the simplest form of unit, data items are the single unit of the data. Entity is like you have more data with some attribute and values. Then similar attributes form an entity set. Then collection of those fields entity are field. Then record consists of all the fields. Then file consists of all the records. Okay. So what was the data structure? It's just the organization where you can store and organize data more efficiently. And if you remember last class, we also discussed primitive and non-primitive data. So primitive data types are
Can you
inbuilt data types, and non-primitive, you can say also derived data types. So those can be again linear and non-linear. Linear data types were arrays, tags, queue, linked list, then non-linear forms were trees and graph. I hope you guys all remember the examples of tree and graph. Then it's same, yes, primitive data structure are the fundamental types, then non-primitive are the derived data types. So advantages were they provide efficient memory use, they are reusable and provide abstraction of the data. Then we also discussed data operation. What was traversing? Traversing, anyone? I gave an example also.
Accessing each record exactly once so that certain items in the record may be processed.
Okay. Then searching.
Searching is finding the locations of all such nodes which satisfy one or more conditions.
Okay. Then insertion. Just insert item.
Insertion is the adding new record to the structure.
Okay. Deleting, you already know. Sorting means.
Sorting is the arranging of the records in some logical order.
Okay. Then merging.
Merging is the combination of the records
Just
into different like
combining two lists or records.
yeah yeah, combining of the records.
Okay. So just next one. Can you all see the slides again? New slides. Can you see?
See,
Okay, so today we will discuss about analysis of algorithm. We'll just start. So what is algorithm? Like your previous classes, it's already written there, and you guys, I have already know what is algorithm. Just step by step
Ye-
instructions
yes ma'am.
to solve a problem. Suppose if I ask you to put a book in the box, then your simple algorithms will be like open the box, then pick up the book and put it there. So for every simple work or any work, we can just give the instruction to the user how we can successfully do a particular task. Now that was for your second sensing, like a very simple way. But now you will get some more advanced information about algorithm. Like last time I said, like you need to follow certain rules. That is correct, but there are no well-defined standard for writing algorithms. Okay, so it will mostly depend on the resource and the problem. So algorithms are never written to support a particular programming code. So it should be programming independent. Okay. So normally we always write programs in a step-by-step manner, but it's not always the case. So algorithm is like a process and is executed after the problem domain is well defined. So first you need to fix the problem domain, then only you can write the algorithm. Like for this example, I am giving you the problem that you need to just put the box in a box. Similarly, you just need to finally know what's your problem, then only you can write an algorithm. So suppose here is an example. You need to design an algorithm to add two numbers. So in a normal way, like last time we did, you can just write step one, step two, first start, then declare three integers a, b, c, then define values of a and b, then add values of a and b, then store that value in another variable c. Then you just print c and stop. This step you already did in second sem, right? You guys remember, right? Respond. This part you already understood, right?
Yes, ma'am.
Okay. So now a bit more advanced because now you have to analyze an algorithm. If you write an algorithm in this way, then it's a bit difficult to analyze it. Okay. So algorithm should be useful for the programmer how to code the program. So alternatively, you can also write an algorithm in this way. Here, your main purpose is to design add two numbers. What you are going to do programmatically. You will just suppose you have a function suppose for adding. So you will just write start add, then get the values of a and b. Then you can just simply write a plus b equal to c. You are just storing that value in c and display c and stop. So both are correct. In the last time, I gave you the simple information how you can write simple algorithm. Now this is like you need to also analyze the algorithm. So you have to also think about programmatically how you can analyze. Then there will be another subject in fourth sem in next year. It will be design and analysis and algorithm. So in that subject, you will get a bit more advanced version. Okay, it's like going, you guys are going step by step. Now, there should be certain characteristics of a good algorithm. Okay, one is your input and output should be well defined. Okay, so you must need to means define your input and output. Then it has another characteristics like finiteness. Means anyone wants to say what is finiteness? Any idea? From the name, can you guess? Finiteness means your algorithm must terminate after a finite number of steps. It cannot just go on and on. It should have defined definite number of steps. Then it should be feasible and it should be feasible with the available resources. Okay, you cannot simply just write an algorithm to solve a problem. You have to also look for the resources. Okay, then it should be clear and unambiguous. Means your each step of one algorithm and their input output should be clear and must lead to only one meaning. It cannot have like dual meanings. Okay. Then I have already mentioned your algorithm should be program independent. Okay. So one algorithm it should be useful for any programming language. So why we need algorithms? It basically helps us to understand the basic idea of a problem. It provides an approach to solve the problem. It's an efficient way and it helps us to understand the flow of problem. And most importantly, to measure the behavior of these matters in all cases, like best case, worst case, average case. I'll come to this point later on. So just moving on. So for analysis of algorithm, what we do, you guys ever heard of time and space complexity? Anyone? Any idea?
Yes, ma'am. Time complexity is the performance requirement,
Okay,
and space complexity is the memory requirement.
okay, memory requirement, very good. So in all the cases, whenever we write an algorithm or if we write any program, from now on, we need to analyze that algorithm in terms of time complexity and space complexity. So time complexity is the running time of the program in reference to the size of the input, and space is also how much space an algorithm or the program will take to complete a task. So clear everyone? Others respond to, are you guys following? One is waiting in the lobby room. Just wait. If Cisco WebEx gets locked itself. Okay. Raise the hand. Can others follow too? And everyone could join now, right? I just unlocked the meeting. Let's lock itself. Okay, let me just stop sharing again and just check once. Someone say can't hear me properly. Can't hear me properly, is it? Can you hear me now?
We can hear you. Yes, ma'am. It's clear.
Okay, maybe just a network issue. Okay, I'm going to share the screen again. See, now to understand the efficiency of an algorithm, there are two different stages. In one stage, we first theoretically analyze a, an algorithm. Okay, so that is also called is like a priori analysis. Means before writing the algorithm, you are going to check like processor speed, then any other resources for your implementation of a program or to solve a problem. You're going to check those resources like processor speed, constant, and others. So those are your theoretical analysis of an algorithm before actually writing the algorithm. Because I already told algorithm is also dependent on resources now. So you have to check those before. Next, after writing an algorithm, you need to analyze it again. So it will be mainly dependent on your programming language. Like if you are writing in C or C++ based on the way you have used, so you need to analyze that algorithm, and that type of after writing analysis is called posterior analysis. Now let's come to space complexity. You guys already know it's just amount of memory space required by the algorithm during the course of its execution. Now it requires like certain components. One is instruction space, data space, and environment space. Anyone want to guess what is this? Instruction space means you guys can hear me, right? Okay, instruction space means it's the space required to store the executable version of your program. So this space will be like fixed, but it will also depend on the number of lines in your code. So if you write a longer program, then it will take more space. Then it also depends on your variable size. Okay, so like you can say it has a fixed part, then it has a variable part. Fixed size will be like your simple variables or constants. Those will be fixed part because your constant always have a fixed length, right, or fixed size. Then your variable space will depend on the size of the problem. Okay. Then next is data space. Data space means is the space required to store all the constants and variables, including temporary variables. So in your program, if you are using a temporary variable, like in case of swapping, if you remember, you always use a temporary variable to initially store the value you want to swap. So those temporary variables will be counted too. So depending all your constant and variables, you need to calculate the space and it will analyze the space complexity. So environment space means is the space required to store environment information needed to resume the suspended program. So any space complexity you can uh, means define using this equation. SP, you can just think P is your program or algorithm, then space complexity of that program or um, algorithm you can represent as C plus SPI. C means is the fixed part and SI is the variable part of the algorithm which depends on the instance of characteristics I. So you can see the example here. Suppose we have a same adding two numbers example. So your algorithm is for sum of two numbers A and B. So you will just starting then you are what you are doing here after adding the number you are additionally adding number 10 and storing that value in C. Then your program is finished. So what will be the space complexity? It's 1 plus 3. Why 1? Anyone wants to say why 1? And why 3? How 3 and 1 comes? Why 3 and why 1? 3 comes because you have three variables A, B and C. So for three variables you got number 3, and 1 is for the constant. You have 110, therefore that will be counted 2. So your space complexity for this particular algorithm will be 3 plus 1, which is 4. So space depends on the data types of the given variables and constants, and it will be multiplied accordingly. So for a long program or big program, suppose you have this part. So for this portion or this code only, you will have space complexity this much. Then there will be other parts too. So for other part also, you need to calculate like this. Then finally, you are going to analyze the whole complexity. Is it clear to you guys how you find space complexity? Respond.
Clear.
Okay. Other than you, others respond too. Okay. Someone said yes, ma'am.
Yes, ma'am.
Yes, ma'am. Okay. 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 Maximum people are saying yes. Next comes your time complexity. See, the space complexity we used to like, it's very important in early days because that time we had like less amount of space. So it was very important to calculate space complexity, correct? But now the case is different. We have like ample amount of storage now. So most of the desktop and laptops have like really good memories. So space complexity is not that important nowadays, but still for this part you need to analyze it. The most important analysis of an algorithm is the time complexity. Means how fast you can write an algorithm or how fast you can solve a problem. So most of the time, even in research, the whole goal is to minimize the time and calculate what's the time complexity. So it's just the amount of time required by the algorithm to run a completion. Okay, so time complexity you can also define. Let me have a sip of water. Okay, so your time requirement can be a numerical function. Okay, so for example, you can see addition of two n-bit numbers. Again, same thing. So your computational time will be C into n. So C is the time taken for the addition of two bits, and n is the number of input size. And you can also say like how many integers you have and with how many steps you have completed your execution. Okay, so time complexity, uh, that calculation you will mostly get in that design and analysis part, but still this time also you need to calculate the time complexity of most of the algorithms. Later. Okay, sorry for the interruption. So time complexity you can basically measure in terms of C and N. C is the time taken for the addition of two bits, and N is just the number of steps they have taken for adding two bit numbers. Sorry, n bit numbers. So time complexity you will analyze in three ways. One is worst case, the best case, and average case. Worst case means last time sorting you guys heard about worst case, best case, and average case, right? Worst case means in case of sorting, I told when your element is at the is the last element. We will come to the sorting part later anyways. So in simple ways, the maximum number of steps taken on any instance of size of n. See, time complexity always depends on the number of input size. So if you are trying to search an item in an array or which have 10 numbers, then your input size is 10. Okay, so it will always depend on the input size. Then the best case is the minimum number of steps taken on any instance, and average case is like the steps taken on any instance of size n. So in next class we will go to asymptotic notation. Have you heard about the term asymptotic notation? Asymptotic notation. Anyone heard? It's something new. So next class I'll discuss asymptotic notation, which are nothing but to calculate the best case, worst case, and average case. Means those are mathematical model to calculate these three cases. So whenever you have to write an algorithm or write a program, you need to calculate the complexity, and we represent any time complexity with asymptotic notation. Like if you remember last time I showed for the linear search, complexity is time complexity is ON. Uh, okay, so it's represented with like three notations: big O, theta, and omega. So those things I'll discuss in next class. Is it clear to you guys what we have went through? Any doubts? No, no, no. Please say no. Okay. Okay. See, your that class rating is not live yet, I guess. So when that one will be live, we will be get notified. Okay. Just stop sharing. Okay. So for your unit one, all videos means most of the topics for unit one is already uploaded in Editu's YouTube channel. Then your class videos will be uploaded in another CSC YouTube channel. So if someone wants to go to the class again or want to, if someone missed the class or someone just not able to hear or something, some network issues or anything, because I know whole day it's not possible for you guys to be online and take video classes from all. So of course you are going to have network issues and all. So if something happens like that, any issues or like that, you can always go to your YouTube channel and check your classes. For all classes, it will be same. Means everyone, not only for me, all of your classes will be uploaded in a channel. Then those links will be shared by your teachers if they make it unlisted. If those are like make it like view is public, then you can always go to the site and see. I'll share the link with you guys very soon. So anything else you want to ask? You guys are still having that AWS enrollment problem, right? Okay. Okay. That thing I already informed IT officer. He said he will look into this, but I guess we are too busy. All of you passed in your second sem, right? Any back or any something? Okay. So everyone passed. Okay. All passed. Very good. Congrats. Because if you get back here, it is going to be a big headache. Always try not to get a back here. Yeah. So, okay. I guess you have your next class. So, I'm going to just stop this class here now. So, next class we will continue from time complexity part, asymptotic notations. Those are mathematical models. So, it's like how you represent time complexity. CSC videos are available on YouTube. Means for some of the subjects, those are available. Like for my subject, Unit One videos are already available. YouTube, that one is Editive YouTube channel. So the topic-wise videos will be available in Editive YouTube, and your class videos will be available in CSC YouTube. So it will be like two channels, a bit confusing for us too. But anyways, that's the rule now. Okay, I'll share both links with you guys. And these notes are already in ERP. You can always go and check. And don't go through the previous notes. Means go too fast. Means when I teach one uh, topic, then you can go through the notes, or you can also go beforehand. Like I already told you guys that next class I'm going to discuss about asymptotic notation. You can just go through those notes beforehand. It will be easier for you guys to understand. So it's just an advice from me, but it's up to you how you choose. So okay, I'm ending the meeting now. Thank you all. See you in the next class. Oye, mata